is perfect. So thank you all. I'm distracted because someone is asking Nereus. Sorry, Elise, could you share with Nereus the link? So thanks a lot. This is a lunch session for Wetlands International colleagues all around the world. This is something we are used to do, so to invite project partners in this lunch session to share intel, also to inform our colleagues on project we are involved in. And this one is particularly interesting for us all, the global network, because it's related to disaster risk reduction. And through MYRIAD, so the project is called MYRIAD-EU, and it's multi-hazard and systemic framework for enhancing risk-informed management and decision-making in the EU. Today with us, we have Professor Dr. Philip Ward. Is a professor of global water risk dynamics, head of global water and climate risk at the Institute for Environmental Studies of the University of Amsterdam, the Vrije Universiteit of Amsterdam. And we have Silvia Torresan from the Centro Euro-Mediterraneo sui Cambiamenti Climatici, so Euro-Mediterranean Center on Climate Change of the Venice University, Italy. And Silvia, so the way we have organized the session today is that Professor Ward will introduce the project in general, explaining you why MYRIAD-EU, what we are aiming at, who the partners are, and what we are going to do in this Horizon 2020 project. So the Horizon 2020 is an EU-funded project on research, and many of the partners are academics, so university. So Dr. Ward, Professor Ward will explain us about the project. And then because the project is composed of pilot cases, Silvia will go and explain we selected the Veneto case, also because one of our members is from Veneto. And so we were quite curious to see how we could better contribute, in particular to the Veneto case, because of our presence in the region. That said, I think we can start, and I can pass to Dr. Ward, Professor Ward. Apologies, Philip.
No problem, and Philip is also okay. So let me just find the share screen. There we go. So hopefully you've seen the full screen with the very purple and pink slide. Yeah. Great. So thank you very much for the introduction, Leah, and also thanks to everyone for joining. It's a nice opportunity to be able to introduce the project to all of you. It's a 4-year project. We started in the end of 2021, and we just finished our 18-month review, so we have two and a half years to go. So the project's really in full swing now. We're starting to produce our first major results, and starting to test a lot of our work in our pilots, which Sylvia will talk about. So I think this is a nice time to be able to talk a little bit about the project. Yeah, so I want to start with an example of these kinds of multi-hazards or multi-risks that we're talking about, just to set the scene. And this is a case study from California, a region which is been well quite commonly used to being affected by droughts. There's been a lot of drought conditions over the last decade to decades, and this drought conditions also means that it really amplifies the chance of wildfires. And indeed, in the season 2020 and 2021 were the first and second most severe wildfire seasons in California on record. At the same time, at the new year, the change from a new year this year, so from 2022 to 2023, the region was actually hit by 12 atmospheric rivers. So basically very large atmospheric systems which dump a lot of rainfall over a very large area. And as a result of this, there was quite extensive flooding. And also this flooding led to landslides. So we can see here lots of different kinds of interactions between different natural hazards. On the one hand, we have consecutive events, so wildfires which are followed by floods, which are not necessarily statistically or physically related to each other, but the fact that they, consecutively occur can really change or increase the impacts of them both. We have kind of triggering kind of hazards. So a lot of rainfall, which falls on an area, can actually trigger a landslide, for example. We have these so-called amplification effects. So because an area has been affected by wildfire, the soil becomes more, susceptible to drier, and when it rains a lot, it amplifies the chance that this will lead to a flood or to a landslide. And the opposite can also be true, right? So in those areas that faced destruction of forests, for example, from the fires, the flooding then can actually lead to rejuvenation, which leads to growth of spring foliage, which can then actually the next season amplify the likelihood of wildfires. So we have all of these very complicated interactions between all of these hazards. I mean, closer to home, we see other kinds of interactions between other hazards. So, for example, in February this year, in Turkey and Syria, I'm sure we all remember the horrific earthquakes that took place, leading to a large number of fatalities, huge damages in those regions. But a few weeks later, in March, actually the same regions were hit by very severe floods. Unrelated to each other, right? The flood and the earthquake in a statistical sense. But the fact that the recovery operations were still, trying to recover from the devastation of the earthquake means that there's also less resources to actually deal with the flood than if they hadn't occurred together. A similar situation in New Zealand earlier this year, where an area which was hit by earthquakes was then hit by cyclones. And again, this really made it difficult in terms of emergency response. Just a few weeks ago, the MYRIAD project had its General Assembly, its annual meeting in Venice. On the second day of that meeting, it was extremely wet, but nowhere near as wet as in the region of Emilia-Romagna across the water, where during our General Assembly there were very devastating floods, which led to huge damages and also loss of life. And these floods occurred on an area which is facing a very long period of severe drought. And this drought can mean that the soil becomes more, less able to absorb the water, which then can amplify the flood. So these kinds of interactions are really commonplace all over the world. And that is, just waiting for the slide to change. Seems to be stuck. Try to slides again. Okay. So my PowerPoint says it's become unstable, which means I will restart it. I hope this doesn't take too long. Okay, there they are again. So do you see the slide, or do I need to reshare now? Yeah, please tell me. Yeah, so sorry about that. So we have all of these different kinds of effects, and we want to look at in MYRIAD how can risk be better managed if we actually consider these different kinds of interrelated effects between the hazards. At the same time, something else that we observed within this project is that measures taken to reduce the risk from one hazard may actually increase the risk from different opposite hazards. So this is what we call synergies. And here's a classic case of this, right? So a house which has been built elevated on these poles above a floodplain, make it less vulnerable to floods, can be more vulnerable to collapse in the event of an earthquake, as we see here. And one of the questions that we pose in MYRIAD is really, how can we better account for these kind of dynamic feedbacks and interactions between drivers of risk, but also between measures taken to reduce risk? And I think specifically of importance to this meeting is also what could be the role of these more nature-based or ecosystem-based approaches in doing this, right? So do they provide us, for example, with more synergies between different kinds of hazards? And this is also one of the reasons why we engage with Wetlands International on this project to address this. What we also look at, we know that there's often interrelated effects across different sectors. And this is a photo of Huntington Beach in Los Angeles. Why do I show this one? Basically because in a very small space, we can see lots of sectors taking place here, right? So we have the tourism sector, recreation, a lot of people enjoying themselves on the beach. We have nature. So the ocean full of the life and also the area behind the beach, and clearly this energy sector right at the back of that beach, all competing for space, and all of these could be impacted by the various hazards that take place in this region. It's on the San Andreas fault, so we have earthquakes, possibly earthquakes, coastal flooding, drought, of course, dry region. So we have to really look at how these sectors depend on and influence each other. So how can we account for these trade-offs and synergies across sectors, regions, and also hazards? And then so this is set in the scene of why we do MYRIAD, and then this is a bit what do we do? We set off with the vision really to try to catalyze a paradigm shift that we think is needed to move towards a more multi-risk, multi-sectoral, and systemic approach to risk assessment and management. Now, this is, quite a lofty vision, right? So it sounds nice in the proposal, but we try to make it into a much more concrete aim. And that aim is that by the end of the project, so in 2.5 years' time, together with decision makers, practitioners, we will actually be able to develop forward-looking disaster risk management pathways, so actual plans on how we can reduce the risk in the future. Sylvia will talk about specifically the Veneto pilot in a minute, but the core of the project is our pilots, or our case studies actually, where we work in 5 different regions of Europe: the Canary Islands, Veneto, Danube, Scandinavia, and the North Sea. Now, what often happens when we carry out a disaster risk assessment is we pose a question such as, what is the flood risk in a certain region, and how can we reduce that flood risk? But in this multi-hazard, multi-risk scene, we want to look at the connections between different hazards, different sectors. So we start actually with a sustainability challenge. And for example, in Scandinavia, future challenge may be how can we maintain healthy ecosystems given climate-related risks, while also meeting increased demands for energy, food, and other ecosystem services in the future. And what could be the role of nature-based solutions in doing this? And then we work backwards. So we look at which sectors could be involved or would need to be involved to think about solutions for these challenges. So in this case, for example, ecosystems and forestry, energy, and food and agriculture. And then we look at all of the different kinds of hazards and interactions between hazards, which could be important to try to address this challenge. So this also shows this figure here, the 6 different sectors which are involved in the project. That is energy, food and agriculture, tourism, ecosystems and forestry, finance, and infrastructure and transport. This is the consortium. So it's a combination of a lot of research institutes and universities, several small and medium enterprises or companies working on developing software, etc., but also institutions from practice. So each of those 6 sectors that I just named, we have a so-called sectoral representative. And so for ecosystems, that is Wetlands International. And the idea is here that by fully involving these sectors within our project, we can really try to make sure that the research going on is also relevant to those sectors, and also that the results are fed back to the sectors and also receive input from the various sectors. I just want to show, without going into any detail, a few of the results that have come out of the project so far. What we noticed at the beginning of the project is there's actually a lot of confusion between different parties, because there's a lot of different terminology, a lot of different definitions, language is used. So we developed a handbook of multi-hazard risk definitions and concepts to try to bring some clarity to this. We then also examined different policies and policy-making processes, governance approaches, which are used to address multi-hazard risk. And I think, importantly, probably the most part that I would like to put here, is that we then try to bring all of this information together in a wiki platform. So this is the disasterriskgateway.net, and this is a real wiki platform, right? So the idea is that anybody can upload a tool, a method, information, knowledge about multi-hazard risk onto this platform, so that it's a real a place for the community to share different knowledge. A key part of the project has been to develop a framework of this multi-hazard risk reduction. I certainly don't want to go through all of these steps now, but it's a 6-step framework, basically, which helps us together with our stakeholders to look at the different steps that one can take to carry out a multi-risk assessment and try to develop a management plan. And the idea is that this framework is tested within the 5 pilots. So we have a kind of iterative process where we develop a framework, we then test it with our stakeholders within that region, we update the framework, we test it again, we update, and so forth. Last year in August, we had the first set of workshops in each of the first pilots to get the initial feedback, and we look forward to that going forward. I'm sure Sylvia will talk about this process for the Veneto region. Maybe one of the results that I will show so far is this DAP-MR approach. DAP stands for Dynamic Adaptive Pathways. Maybe some of you are familiar with this concept, maybe others not, but basically this is the idea which has been used in single hazard risk assessment in the past. For example, it was used in developing different flood strategies for the Thames River in the Thames Estuary in the UK. And the idea is that there are different strategies that one could take at different points in time. And that at certain points in time, you may cross a threshold where some options no longer work. So you would need to move to a different kind of option. For example, maybe for the next 20 years, you can you don't need to build a huge barrier, for example, but you could reduce the risk by doing spatial planning. However, at some point, you may need to look at a more systemic change. And the idea is that you develop these kind of metro maps that show the points in time where you would need to actually take these decisions. Now, what we're trying to do in MYRIAD is to make that usable also in this multi-risk, multi-sector setting, where you have different interests from different people. You have to look at those trade-offs and synergies. So far, we have a very conceptual analysis of what this looks like, and then it will be implemented in the case studies in the coming years. I'm going to skip that one in the interest of time. But Leah asked me to briefly touch on a study which we're carrying out now, the global scale. And this is a study where we want to look at different pairs of events and compare them in the past. This builds on some work last year by Heidi Kreivik, colleague from Potsdam, and Heidi led a study where we looked at areas where there has been 2 floods or 2 droughts in the past. And what we did is we looked at the impacts of the second flood or the second drought compared to the first one. So we looked at were the impacts of the second event lower or higher than the first one. And then we tried to see why that was the case, right? So were there measures taken after the first event to try to reduce the risk? And did they actually lead to lower risk in the second event, for example? Now, it's quite a complex study, so I don't want to go into this in detail. But basically, we looked at 45 different pairs of events that have happened throughout the world. And then we looked at whether the impacts decreased in the second event or increased. And that's what we see here. So blue means that the second event had a lower impact. This one, these dots mean that the impact was more or less the same in the first and second event. And orange or red means that the impact in the second event was higher. Now, we then looked at how what kind of adaptation measures had been taken between the first and second event. And what we found is in most cases, actually measures had been taken to reduce the vulnerability and also to address management shortcomings that occurred during the first flood or the first drought. So that's positive news. We then also looked at how did the hazard itself actually change between the first and the second. So was the first flood itself bigger than the second flood? Was the second drought, in a physical sense, more severe than the first drought? And then the picture here is a little bit more mixed, right? So what we see is actually that when we have these for these events where there was a lower impact or no change in impact, we see that actually oftentimes the hazard was also lower or slightly higher. But when we have a very big hazard, which hasn't been experienced in the past, still we can see an increase in the impact, even though lots of adaptation measures have been taken in the meantime. So this shows that these really unprecedented events are often not actually well managed by some of our adaptation measures. So that was quite a long story to introduce this part. The idea going forward is that we would now repeat this study, but then also for any kind of pairs of multi-hazards. So not just floods and droughts, but just in the same region, there's been one event and a second event. And we are trying to do now an international study where we look at these cases and try to tease out what kind of management strategies work in which regions. And I think particularly interesting would be to see what is the role of nature-based solutions in this. And do we see these kind of cases where measures have been taken following a first hazard, which led to a reduction in impacts in a second hazard? So it would be interesting to hear from any of you if you are aware of such cases that we can include in this analysis. And then I'm going to wrap up. I just want to show this slide to advertise that next year, in the 12th to 14th of June, we are planning to have a conference, an international conference, where we look at this topic of addressing compound and multi-hazard risk. It will take place in Amsterdam, and we already have a email address that you can actually send to get information and updates about this. So that was it. This was a very brief overview of the MYRIAD project.
Thanks a lot, Philip. I think maybe if you agree, maybe we could go for a first round of questions. And then we go to the pilot case, Veneto pilot case. And then we ask for question for Silvia. And then if there are additional questions, we just wait at the end. But if there are any questions for Professor Ward now for this first part, please raise your hand. Or any clarification. I see that Elise, I don't know if you want to share your comment in the chat so that everyone can.
I do that. And actually, well, hi everyone. Good morning or good afternoon. I'm Elise, working with Wetlands International and peatlands. Very interesting insights. Thank you very much, Philip. Yeah, what I shared in the chat, it was just yesterday I was listening to an interview about fires, in this case in France, and there was this fireman actually talking about the need for this, let's say, apprehension of multi-risk within, you know, the way that they're addressing fires. And you mentioned the importance of the terminology. So again, I'm not sure whether I'm using the correct terminology here, whether he was mentioning the need to approach multi-hazards or multi-risk, but I thought it was an interesting link with what I heard yesterday, and what I also put in the chat is maybe the interesting alliances or interesting insights that you can get from such practitioners in this type of projects, because yeah, a lot of them are facing those various risks already, and you've shown us some examples. So just to share this. Thank you.
No, thank you. I think that's very common. And also I think I've just this year in the media seen several people actually in the media now talking about multi-risks, multi-hazards, which I've never seen before actually. So this is an interesting, I would say, positive development. And I think there's actually more and more recognition that, you know, when we talk about multi-hazard, multi-risk, that most hazards actually have a multi-component. Often the very big events are a combination of different factors actually. And so this means that just more generally, I think one of the important things is that we have this more integral look at how we approach our systems, which I also personally believe that you know, ecosystem-based approaches can play a role in doing just this. Maybe coming back to your comment about the fire person, I think this is indeed a good example. We also had some workshop early this year in Glasgow where there were people from train operations also present, and they were also completely you know, stressing how important it was for their planning of, you know, what to do in the case of these hazards to get water. And I think in Sylvia's case, so in the Veneto, there's quite a lot of interaction with the Civil Protection Agency as well, who also mentions some of these kinds of points. Thank you.
Sorry, I see Nupur, please.
Yeah, hi, thank you, Philip. My question is, does the proposed framework and the approach also take into account the man-made cascading pressures or risks that exacerbate the hazards further? Does it also account that and put it as a feedback or a learning mechanism or something? Thank you.
That's an excellent question. We have tried to set up the framework as being generic enough that it hopefully could indeed be used to address those kinds of events. Because also I think that in a lot of events there is this human-made element, right, which somehow increases or decreases, by the way, the impact. So that is the idea that would be that should be able to take it into account. Yeah.
Thank you.
Okay. At the moment, I don't see any other hands. So maybe we could go to Sylvia and come back in case at the end people would like to ask questions to Philip. Please, Sylvia.
Thank you.
So, do you see the screen?
Yes, but not in a presentation mode.
Yes, I'm trying now to switch to the presentation. Maybe.
Okay.
The
Yes.
bar, I want to, okay.
This way.
Okay. Thank you for the invitation to this seminar. In my presentation, I wanted to show you what we are doing and planning to do within the MYRIAD-EU project for the Veneto pilot, with a focus on a tool that we want to implement and upgrade in the project, which is a sort of intelligent multi-risk assessment tool. And sorry, but how can I? Do you see the bar still? I don't know how can I hide the bar.
What do you mean?
We don't see it. So
You don't see it. Okay, I only see it. Okay, it's quite annoying. No. Okay, we'll try to do, because I have this black bar. No. Okay, we'll try to do anyway. Okay, first of all, a couple of words regarding my research center, the Euro-Mediterranean Center on Climate Change. We are focused on analysis of the climate system and its multiple interaction with the society and the environment in order to help the decision-making around the process of climate mitigation and adaptation strategies. We are composing different research divisions, which are also based in different cities in Italy. And I am the co-director of the Risk Assessment and Adaptation Strategies division that is based in Venice. And where we have also established a research center together with the Ca' Foscari University of Venice, the so-called CMCC at Ca' Foscari, which brings together really an interdisciplinary team of experts, including economists, but also environmental scientists, spatial planners, and so on. And we are all committed into the innovation of risk assessment methodologies and decision support tools that can also take into consideration the multi-hazard interrelationships, the effects of climate change and climate extremes on the occurrence of damages and risks, not only socioeconomic, but also environmental risks. And for this reason, we also take into account how different climate and non-climate drivers could also affect the distribution and occurrence of such risks. In my presentation, we start with a quick introduction about the study area that maybe you are not all of you are aware about it, and then I will show some stock taking and desk review activities that we have done within MYRIAD-EU project, and then I will show some results that we already obtained through the application of machine learning in another project for the coastal municipalities, in order to give you an idea about more concrete idea about the kind of results and the kind of analysis that we are going to do in the Veneto pilot, and to conclude with the next steps and the future implementation of this model within MYRIAD-EU. The Veneto case study the Veneto region is really full of different landscapes. As you can see in this map, we have the mountains, the Dolomites, but also the Po River Plain and the Venice Lagoon area and the Po River Delta. So really we have different issues and different vulnerabilities, and also the territory is prone to different hazards, and also this variety of hazards interact across different scales and different landscapes. And we have a lot of ecosystems and natural resources that are very important also for the development of socioeconomic activities, mainly tourism, but also agriculture and industrial activities are important in this region. And so then for the natural hazards and disasters, we have seen also in recent years that our region is very much vulnerable to coastal flooding. And we know the fragility of Venice for this, and also the latest events that we had in 2019 before the testing of the MOSE project related to the high tide and coastal flooding in Venice, but we also have vulnerabilities related to tornadoes, storms, fires, and also to the drought. And it's not only natural hazard, but also anthropogenic hazards, which are generating increasing pollution and overexploitation of the natural resources. And so there is a problem also of contamination and of environmental risks in this region. And so we have natural hazards that can combine with anthropogenic hazards, and all of this can be amplified by the climate change, because we have of course, the problem of increasing temperature, but also increasing sea levels, and the changing of rainfall and precipitation extremes, as many other regions in Europe and worldwide. And so in MYRIAD-EU, our main overarching challenge is to analyze how can different natural landscapes from mountain to the sea achieve a multi-risk perspective in the future planning and future mitigation of risks, and also in climate change adaptation. We are going to look specifically also at the interaction between natural hazards, anthropogenic hazards, and climate change, and how they affect different sectors. The main sectors that we want to analyze in the project are ecosystems and forestry, but also finance and tourism. And you can see here in this picture that we want to analyze the different and multiple hazards and their interactions as well, with the final aim to develop disaster risk management pathways that can take into account the multi-hazard interaction, but also the climate change scenarios. Okay, this is a very complex and ambitious objective, and for this reason, the first steps that we have done in MYRIAD are also related to stock taking and a desk review, in order to see what has already been done in the Veneto region to really analyze and disentangle multi-hazard risks affecting the region. So we have reviewed the scientific literature on this, and we have noticed that anyway, there are already some studies which address some combination of impact, especially in the coastal area, where flooding is analyzed in combination with sea level and saltwater intrusion and extreme storms. And then there are also already existing studies related to the impact of precipitation and drought on water quality, for instance, or on agriculture. And also in the mountain region, a main focus and a main concern is related to landslide and extreme storms. And also an emerging issue that we have observed, especially during the last year, but also this winter, before this spring at least, is related to drought and the potential consequence for different sectors and landscapes, and also from mountain to the sea, related to this lack of water. And we, in parallel, started to think about what would have been the best method for us to be able to analyze and disentangle these complex multi-hazard and multi-risk interactions. And we have identified machine learning and artificial intelligence tools as promising methods that are increasingly being applied also in the scientific community in the recent years to tackle natural hazard and climate change risks, and because they really can help us in analyzing complex relationships among hazard exposure and vulnerability factors, and also at a different scales. And so we would we have identified the machine learning as a suitable tool to help us in analyzing the risk related to multi-hazard events at a different temporal and spatial scales, but also for the future climate change scenarios, and also to take into account the potential effects for different systems and sectors. In order to apply data-driven methods, one of the main important thing is also to collect data that can help us in characterizing the territory with a high granularity in terms of spatial and temporal resolution. So we have also started to collect a wide array of data regarding the multiple hazards that I showed you, and these come from mainly the meteorological observation network of the regional environmental protection agencies, but also from the analysis of available global data sets such as Copernicus. And also we need to have and analyze data regarding future climate change scenarios, which are downscaled also and bias corrected in our region. Then also we are analyzing and collecting information about the territory, including the land use, but also the topography, the population density and distribution, and the presence of other elements at risks, such as forests. And for us, it's particularly important, and also it's a sort of bottleneck, the availability of data related to the impacts already observed in relation to natural hazard or extreme climate events and so on. For this reason, we are also trying to get in contact with some stakeholders, because this information is fragmented in our region across different offices of public authorities, but also across different sectors. And so we have established also some contacts with our stakeholders to be able to get impact data as much as possible, not only for the socioeconomic part, but also for the ecological and environmental impacts. And apart from the stock-taking activities, we have also prepared during the first year of the project the first workshop in our pilot region with our stakeholders, where we have discussed about the complexity of the riskscapes of the Veneto region, and also try to understand with them if what we have identified as major risk and major vulnerabilities of the region were also for them important, or if they were some more issues that would have been important for them to be addressed in the project. And we discussed in this participatory process with them the main challenges that we would like to analyze within MYRIAD-EU to be able to develop together with them the disaster risk management pathways. Also to test with them some of the main products that will be delivered by MYRIAD-EU, such as the systemic risk framework, and also other tools and methods that will be provided by our partners in the project. As you can see here, the main challenges that we have identified so far are related to really the analysis of multi-hazard spatial temporal footprints and the dynamic, because usually also in the Veneto region they address individual hazards separately, but lose the vision of how this may interact and propagate in the territory, and also have cumulative effects in the territory. And also they recognize it's important to analyze the cascading risks of these multi-hazard events across the landscapes and on different sectors, as well as the effect of climate change. And also they felt and they share with us that still there is really a lack of coordination in the governance of risks in order to be able to cope with the multiplicity of hazards and potential co-occurrence or cascading events. So within this project, the next activity of the project, we will try to make some analysis that can help to analyze these challenges. And also based on the desk review, the stock-taking activities that we have done and the interaction with the stakeholders, we were able to identify a first multi-risk conceptual model. And you can see here that we have tried to put into this framework a lot of hazard interactions that can affect our region. You can see in pink and orange, for instance, the hazards that may be related to extreme heat and lack of water, so to hot and dry conditions that can determine hydrological drought, but also ecological impacts then. And then in blue, we have also highlighted on the other side the hazards that can be related to extreme precipitation events and to flood, both in the rivers, but also in the coastal area. We have the combination of the floods with the coastal flood, the relative sea level rise, and the extreme storms. So this is extremely complicated hazard overview. Then interacts with exposure and vulnerability factors on the territory, and these exposure and vulnerability factors can amplify the effect of hazards on the system and sectors, which we in our model call assessment endpoints. And for assessment endpoints, we are considering several such economic impacts, such as damages to infrastructure, building properties, agriculture and population. And also, hopefully, if we will have enough data, we will be able to analyze also a bit of consequences for the tourism sector. But we give also importance to the environmental targets. And so we would like to analyze the effect of natural hazard combined with climate change and anthropic hazard on the quality and river quality, but also on the ecosystems and especially in vegetation coverage. And okay. Now, as I said, I would like to give you an overview of the type of risk assessment model that we want to develop, starting from the first prototype that we have already tested for the coastal municipalities of the Veneto region in the AdriaClean project. And you know that also the coastal areas are vulnerable to multiple risks, and these include sea level rise mainly, but also coastal erosion, heat wave drought, heavy precipitation, and pollution of waters. In this project, we have developed an integrated machine learning approach that can help us to analyze the impact of extreme events related to storms and how storms can be amplified by sea level rise, and also related to heavy precipitation events. And we have done this model in order to analyze the main drivers of risk and be able to estimate the impacts that can be due to extreme weather and sea level events on the coastal municipalities, in order, in the end, to be able to provide a support for decision making and climate change adaptation in the coastal municipalities of Veneto. Our model learns from the past, so it has to be trained and validated with past data on hazard exposure and vulnerability and observe the impacts in the past. And once we have checked that the model performs quite well in the past, in the reference period, we've observed data, we can also use it to project future risk scenarios based on future climate projections coming from available numerical climate models. So this is the study area that we have analyzed so far, the coastal municipalities of Veneto, and this slide also summarizes the dataset that we have used to train our model, which include mainly atmospheric data related to precipitation, temperature, humidity, and wind, but also extreme sea levels, and also the future climate scenarios that we have used for the period 2020-2050 and for the RCP 8.5 scenario. And then we have also integrated in and analyzed in the model some exposure and vulnerability data. And the dataset which has been more important for us to develop the model is the data on past damages and impacts related to extreme events in the coastal municipalities. This data has been provided by us by the Veneto region, and especially by the civil protection of the Veneto region, where they store the data related to the state of crisis triggered by extreme weather events in the region. So we have been able to analyze for each day in the reference period, which was the time frame from 2009 till 2019. We were able to identify the days featured by damages to the infrastructure, to the population, to the agriculture, and to economic activities in the coastal municipalities of Veneto. Also, we applied a methodological approach, which is composed of 3 main steps. Firstly, we analyze the data in the reference time frame for the assessment of daily impacts. So we developed an index that can help us in having probability of impact happening in a given day in a given municipality based on all the information and indicators regarding atmospheric and sea level indicators that I've shown before. Then in the next step, we moved from the daily to the yearly estimation because we want to have a model that is able to be used also in the future climate change scenarios. And this means that we can't, it doesn't make sense to have a daily estimate of future impacts looking at the future climate, going to the uncertainty also of the climate change. So we had to aggregate and provide information on the yearly frequency of days that can have impacts in each municipality of Veneto. And finally, we have done this reference periods, and finally in the future period, we're looking also at the future climate projections. Now, I'm showing some results. For the daily risk estimation, the objective was to estimate the probability of an impact happening on a given day in the Veneto coastal municipalities. We trained and validated the model with a good accuracy of 90%. And also we were able to analyze the most important factors triggering the extreme events, which include the sea level, but also the precipitation and the wind mainly, through the feature importance. And then once we have seen that the model worked quite well for the daily analysis in the reference periods, we move to the yearly estimation in the reference period. And we can see that also in this case, our model performs quite well because it is able to predict the recorded damages, which are in orange, quite well. The prediction is in blue. And this works both for the training and validation set and in the test set, of course. And once we have analyzed the performance in the reference, we move to the assessment of future risks. And for doing this, we have taken the data from a numerical modeling chain, which helps us to have RCP 8.5 future climate scenario for the up to 2050, both for the atmosphere, precipitation, temperature, wind, related parameters, and for the sea. And based on this, we were able to use the model to project the future damages and impacts for the coastal municipalities and under the climate change stressors. And we can see that there is with a growing impact trend. And looking about why we have this trend, we have realized that mainly the trend of impacts follow the trend of sea level extremes, which is related from one side to sea level rise, but also to the influence of sea level rise on extreme storm surge events. And we have also noticed that the combination of wind and extreme sea level, which is the green curve, adds also further damages to the trend. So it's an amplifying factor. And also here, if we look at the trend of damages, and especially at the fact that our curve of the damages has a lot of peaks, this is due to the extreme precipitation peaks mainly, and which is the red line. And if we combine the red line with the wind, we can also see that we have an further increase in the impact trend. So just to conclude, with the analysis that we have done so far and the research we have done so far, it seems that the new technologies such as artificial intelligence and machine learning are promising to help us in developing a decision support tool that can predict also the impacts caused by extreme events and climate change in the area. The more accurate is the impact data that we can have as input to our model, the more our model can be accurate, also to project the impacts at a better spatial resolution, for instance, and also for more assessment endpoints, because we have focused so far mainly on the impacts on the impacts for the economy of the territory, but we want also to analyze the impacts to the environment. So we are now also looking at how we can integrate more indicators and assessment endpoints for these sectors into our model. And so in MYRIAD, we are going to upscale this model in order to consider all the Veneto region, and so all the municipalities of the Veneto region, in order to extend the hazard sets that we can analyze, including also extreme heat and drought events, for instance, and others that are important for MYRIAD. And yes, of course, the extension of the model includes the analysis of risks to different sectors, and also we want to see how this risk propagate from one landscape to the other within the Veneto region, and if they are trade-off among these risks when we combine together the indicators. Okay, I think I can stop here, and now, yeah, thank you for the attention, and I'm available to answer any questions.
Thanks a lot, Silvia. Super interesting, quite complex, I think, so, in some points, but I think some of my colleagues understand well this data. So I don't know, I would like to open the floor if there is anyone who would like to ask question to Silvia on this specific case, pilot case, or to Philip. Now is your moment. Don't be shy.
I have one.
Please, Odette.
Yeah, maybe I missed it, but I was thinking, how big is the difference between all these small regions in the Veneto is called?
Yeah.
Because all it seems that they have this, well, they have coastal, well, they are geographically near to the sea, and you said that the impact, it's really related with the sea and the winds. And I was thinking if you see significant differences in the impact between these regions, or do you think that is more or less homogeneous because they are near to the sea and then they have more or less the same impacts?
Yeah, I can say that the impacts related to the sea maybe are more or less the same across all the municipalities. The hazard at least, but the vulnerabilities are different. So where you have urban areas, you have more damages compared to when where you have agricultural land or natural land. So yeah, the main difference maybe is on the land use and so on.
And Silvia, sorry, I would like also to ask something, because so this project is aiming at influencing decision makers and policy makers. In your case, how do you think that? So, to whom are you addressing? Who is your governmental target? Is the Veneto region? Is the different municipalities? Who are you? Who are you targeting, and how do you think these decision makers could benefit or will use, or are they going to use it to embed it into the regional strategy? How is in practice to be?
Okay, so our strategy was to try to engage with many different stakeholders and public authorities, both at the regional scale, mainly the Veneto region, the regional environmental agencies, but also we were open and we engage in our networks some representatives of the provinces of Veneto and of some more vulnerable municipalities like Venice. So we were really trying to engage with risk management authorities at different scales, from the regional to the local scale. And also there, we try to have on board different departments. So the Civil Protection Department, the Environmental Protection Department, the Civil Works, the engineering, the offices in charge of developing the risk mitigation works and defense structures. And also, we engaged representatives of the different sectors, like the banks, the insurance companies, and also NGOs of citizens, also for the protection of the environment. And yeah, we really had this broad stakeholder engagement strategy, I would say. And for them, another value was also to participate in our workshop and share their vision and their piece of knowledge, and recognizing that in the end, further coordination would be really needed to be able to analyze the multi-risk challenges in the territory. Because there is still fragmentation of governance, fragmentation of data, and fragmentation of policies, whatever. So, yeah.
So before going to Teresa, I see that Nupur wrote a message in the chat. So she wrote, "Thank you for the study and sharing, and sharing it with us. I want to know was choosing data between 2009-2019 a specific choice? If so, why? And because 2020, because of COVID, exacerbating more risks."
Yeah. We had some constraints because for the data related to the extreme events, we only had the opportunity to get them till 2019. And so since this was the assessment endpoint in our model, we had to focus on this time frame. But if new data will be available soon, we are going to extend the time frame or even after. Okay, and I also think it's important to include the time frame of COVID, especially to get an overview also of the environmental parameters in that period, which were quite strange, especially in Venice for the water quality, for instance. So it would be very interesting.
Thanks. Teresa.
Thank you, Leia. My question is coming after what Leia also asked. So as a former risk assessment, or I was doing multi-hazards and hazard mapping in my previous life. My difficulties was actually the civil servants didn't have the capacity. So are you envisioning building the capacity of civil servants in the municipalities with these studies, or how are you connecting other universities or other research institutes to spread this knowledge?
Mm-hmm. No, thank you. This is quite important point, and also it's true. I can say that sometimes they want to do things, but they don't have the capacity, so they're also happy to be able to cooperate with us. In the MYRIAD project, I think we are going to have some small focus group events where we can even try to make more training for a small group of people on our tools. And so this can be a sort of also capacity building opportunities for them, I think. And yeah, but I don't know, we'll see. We will share with them for sure also the tools and the software that will be developed by MYRIAD, and we'll ask them if they want to try to use it.
Right.
Some webinars also will be organized at the project level regarding this. Maybe Philip can add something, but yeah, it's important impact of our project too.
Yeah, no, it's I can add a few words. It's a good point, very good question. I mean, so I think it's what Sylvia says, right? So we design this also in a way with our first workshop that we're trying to listen to what are the needs in terms of method tool development from those potential users, and that we then therefore try to develop methods that are useful. And indeed, we have these focus groups where we will try to help with that. But you're right, it's not it's a research project, and it's not primarily a capacity building project, right? So I think we are looking for opportunities to connect to other projects where we can try to synergize and cooperate with others as well, I think. Yeah.
Maybe second phase.
Yeah.
Yeah, I think Bruno from SIR.
Yeah,
Veneto.
thank you. Yeah, I'm from Veneto, but I'm here for the Italian Center for River Restoration. Just one question. I don't know if it's better Philip or Silvia, but focusing on flood risk and droughts. When we promote river restoration, one of our assumptions is that natural rivers works better also in reducing risks, flood risk in particular, but also droughts. On the contrary, also, for example, after the last flood in Emilia-Romagna, there is also a contrary approach which want to artificialize rivers, increase the number of dams, and so on. So for us to have the opportunity to promote river restoration, is very useful to have numbers which demonstrate that at a basic scale, for example, in different scenarios, if you have more natural river, they give a better contribution to reduce flood risk than artificializing rivers. But when we look for such a kind of number, it's not so obvious to obtain them because they require a big effort. So my question is if from MYRIAD we can expect something like that, at least from one case study, because it's very useful for to promote restoration, to have number to demonstrate that restoring ecosystem allows to solve hazard problem and to reduce some risks. Also in Veneto, after the last big storm Vaia, I live in the mountain, the Dolomites, the reaction was to artificialize all the rivers again. I don't think this is the correct approach because, if we have artificialized river, we increase the velocity of water, and I think in the next time the problem will be still there. So if MYRIAD we provide such a kind of analysis, it would be very, very useful to have argument to promote river, but I think also wetland and coastal restoration.
Yeah, no, this is quite interesting and also quite important, I would say. Yeah, I think our focus, in the Veneto pilot is now more to look at the effect of climate change on multi-hazard events. We will see whether we can try to quantify with some parameter also the effect of natural-based solution or ecosystem restoration. But it depends if we have some also input data that are reasonable in terms of measure that can help to mitigate this. Maybe we can ask this to our stakeholder network and see whether it makes sense to have later in the project, maybe when we have already trained and validated our model with the data. If we have the possibility to make some scenario like this, we will try. I cannot tell yes now, but yeah, thanks for the nice idea.
For example, Silvia, in the area where you work, the Acque Risorgive Consortia, give more room to many river, but I know that they didn't simulate the hydraulic effect of such restoration. But yeah, thank you for this. But I just want to put a point that such a kind of number from the research for us are very, very useful to convince the decision maker about the importance of not always acting with new engineer work, but also leaving more room to river and so on.
Yeah, very interesting comment, and I think Sylvia answered from the pilot's perspective. I don't think that we'll get like this number from MYRIAD that you want, but I do have on a different project, so maybe it's interesting for you. we have done a global analysis for coastal, not for river flooding, but for coastal flooding, looking at ecosystem-based alternatives, and I'd be happy to share that work with you. So you can drop me an email.
But if you can share, probably I'm not the only one interested. Also in the chat, I don't know. It would be very useful for us. Yeah, because coastal is strictly connected to rivers. Thank you.
Maybe Philip, you can share it with me, and then when I share the recording of this meeting and the deliverables, the handbook, and the other products, I can also share the study that you mentioned.
That's good. I will try to do it. If I forget, please do.
I will remind you.
Yeah.
Thank to both.
Any other question before I close the meeting? Because I think colleagues and you all have to go back to your own tasks. Okay, if not, then I would like to thank Philip and Sylvia for your time, for your presentations. It was super useful, and I'm sure that the colleagues have appreciated. And I would like also to invite colleagues to look into the information that Philip shared on the international conference that will be organized next year, because there will be, so we could apply for with an abstract to participate in a session. So we could propose a session that look at the EU and also global. But we can discuss this at a later stage. And I would get in touch with you because, you know, we as a sector representative need to feed the different aspect of the project. So I will come back to you in case we need global feedback, but with EU colleagues, I will be more present. But thanks you all for being here today, and we keep in touch. Thank you and bye-bye.
Have a nice day. Bye-bye.
Bye.
Bye.
Thanks.